In this session, we will discuss estimation of total factor productivity. Total factor productivity, also called multi-factor productivity, is a measure of the increase in output above and beyond the increases in the inputs. I will first explain the primal approach to estimating TFP, then briefly the dual approach, and finally issues in estimation. In the primal approach to estimating total factor productivity, there are broadly two sets of methods. One is parametric methods. They depend on specific assumptions about a functional form relationship between the inputs and the output. The two most common functional forms are the Cobb-Douglas and the translog. There are also non-parametric methods used in the primal approach to estimating total factor productivity. The most prominent is data envelopment analysis. In this review, we will focus on parametric methods using the Cobb-Douglas functional form. This equation describes the Cobb-Douglas production function. Y, output, in unit I and period t, is a function of A subscript IT, A is the measure of total factor productivity, and the production function. The production function is increasing in the services of capital, K subscript IT, labor, L subscript IT, and intermediate inputs, M subscript IT. The Cobb-Douglas production function is a particular assumption about this production function F. It is that F of K, L, and M is expressed as K subscript IT to the power alpha K, L subscript IT to the power of alpha L, and M subscript IT to the power of alpha M. This is the Cobb-Douglas functional form. And the coefficients, the alpha K, the alpha L, and the alpha M, are the shares of the inputs in the value added. These are the inputs: services of capital, services of labor, and the intermediate inputs. And they're the inputs that go into the production of the output, Y subscript IT. The alpha K, alpha L, alpha M are the shares of the inputs in the value added. This will become clearer when I take logarithms of this production function. Depending on these shares, whether they are they're all positive, but depending on whether the shares sum to one, less than 1, sum to 1, or sum to more than 1, that will determine whether the production function exhibits decreasing, constant, or increasing returns to scale. If the shares sum to less than 1, then a proportional increase in each of these inputs will lead to a less than proportional increase in output. That's a case of decreasing returns to scale. If these shares sum to more than 1, then same proportional increase in K, L, and M will lead to a more than proportional increase in output. And that's a case of increasing returns to scale. To estimate total factor productivity, let's focus on this equation and take logarithms. So on the left-hand side, we have the log of output. And on the right-hand side, we have the logarithm of this product term. And when we simplify in logs, we get logarithm of A plus alpha K times logarithm of K plus alpha L times logarithm of L plus alpha M times logarithm of M. And this log expression of the Cobb-Douglas production function helps us to see clearly that the coefficients alpha K, alpha L, alpha M are the shares of the inputs, these inputs in value added. The next step towards estimating total vector productivity is to take the total derivative of this logarithm expression. So we have the change in the logarithm of output is equal to the change in the logarithm of total vector productivity plus alpha times the change in log of capital plus alpha L times change in log of labor plus alpha M times change in log of intermediate outputs. Now recall that the change in log of y is just the change in y divided by y itself. Remembering this piece of algebra and applying it to each of these 5 variables, we have the proportionate change in output is equal to the proportionate change in total vector productivity plus the weighted sum of the proportionate changes in the inputs, proportionate change in capital, proportionate change in labor, proportionate change in intermediate inputs, the weighted sum of the proportionate change in inputs weighted by their respective input shares. From the previous slide, we had this equation. The proportionate change in output is equal to the proportionate change in total vector productivity plus the weighted sum of the proportionate changes in inputs, where each proportionate change in input was weighted by its respective input share. Let's take this equation, keep the proportionate change in total vector productivity on by itself, and then move these terms, the proportionate change in inputs, to the left-hand side. And rearranging a little bit, we will have that the proportionate change in total vector productivity is the proportionate change in output minus the proportionate share changes, minus the weighted sum of the proportionate changes in inputs, each weighted by the respective input share. Adding an error term, this becomes our estimation model. So in words, the growth in TFP, which is this proportionate change in total vector productivity, is the growth in output, which is this proportionate change in Y, minus the weighted sum in the growth of inputs, which is this. Because no estimation model can be perfect, there will always be some error. To summarize, the estimate of total vector productivity is a residual. It's a residual from the difference between the growth in output minus the weighted sum of the growth in inputs. Another aspect worth noting is that each of these terms is a proportion, so it's independent of units. If, say, we measure Y in tons per year, then the delta Y on top of output will be measured in tons per year. The Y below will be also measured in tons per year. So when we take the ratio, the tons per year will cancel out. So each of these measures, proportionate measures, will be independent of units. What we do to estimate total vector productivity is to apply multiple regression to estimate this equation. The yellow terms highlighted in yellow are the data we need. We need data on output, change in output, change in capital services, change in labor, and change in intermediate inputs. In some applications, researchers prefer to use a simpler version of the production function which ignores intermediate inputs. In essence, they're considering analyzing the entire production chain from the very basics right up to the finished product. In that case, the total factor productivity does not include a term, estimation does not include a term involving the intermediate inputs, and it's just proportionate change in output minus the weighted sum of the proportionate change in inputs, considering only the change in capital and the change in labor. Next, I will review the dual approach, focusing on the parametric method. The dual approach starts from the national income accounting equation, where value added is the sum of the expenditure on capital services plus the sum of the wage bill. Y subscript IT is total value added, total output. R subscript IT is the rental of capital. K subscript IT is the services of capital. W subscript IT is the wage. L subscript IT is labor. Taking this equation and considering the total derivative, the change in output or value added is equal to the expenditure on capital times the proportionate change in the rental rate plus the proportionate change in capital services plus the total wage bill times the proportionate change in wage plus the proportionate change in labor services. The next step towards the estimation is to divide this entire equation throughout by output or value added, Y subscript IT. So on the left-hand side, we have delta Y divided by Y, which is the proportionate change in output. And the next, we divide this by YIT, so it's R subscript IT, K subscript IT divided by Y subscript IT. That is just the capital share of output. The terms within brackets remain the same. And then likewise for labor, we divide W subscript IT, L subscript IT by Y subscript IT. That's just the labor share of output, and then the terms in brackets remain the same. Then we substitute for the input shares. You recognize from our discussion of the primal approach to TFP estimation that RK divided by Y is just alpha K, the share of capital in output. WL divided by Y is just the labor share of output. So if we substitute for these shares using alpha K and alpha L, we get this equation. Proportionate change in income is alpha K times these proportionate changes in rental and capital, alpha plus alpha L times the proportionate changes in wages and labor. From the previous slide, we take the last equation and rearrange a little bit, and we will have the proportionate change in output minus the capital share times the proportionate change in capital minus the labor share times the proportionate change in labor is equal to the capital share times the proportionate change in the rental of capital plus the labor share times the proportionate change in wages. Focusing on the left-hand side, you recognize this as the growth of TFP. It's the increase in the output above and beyond the increases in the inputs. That's just TFP. And the right-hand side of this equation is the weighted sum of the changes in input prices, the inputs of capital, inputs of labor, weighted by the respective input shares. So this is the equation that we'll use to estimate TFP growth using the dual method. And just as in the primal method, we would add an error term and then apply ordinary least squares. Finally, let's discuss some issues in the practical estimation of TFP. The probably biggest set of issues concerns the measurement of output and measurement of inputs. So ideally, both inputs and outputs will be of uniform quality over time. So we just measure the physical quantity in units like hours or weight or flow. But it's not so simple, really. Say if we think of an hour of physician services and we compare 1 hour in 1980 vis-a-vis 1 hour today, or in a context closer to home, an hour of lectures in 1980 as compared with an hour of lectures today. Hopefully, I say hopefully, the quality of both should be much higher today than in 1980, so that 1 hour represents a different degree of welfare contribution. So one approach to adjusting for differences in quality is to use prices. So if people are willing to pay more for one physician than another physician, we might say, well, the one which people pay more for is a better physician, providing better services. So that same hour provided by that physician is worth more. It can help, but the trouble is then the prices are distorted by the market power of buyer and seller. So it could be that one physician charges a higher price, not because she delivers higher quality services, but just because she has more market power. So that's a very important proviso to bear in mind. The same issues arise in measuring inputs, and both capital and labor. So for capital, if you have an example in agriculture where the capital stock changed from a wooden plow to a set of animals and an animal plow, and then a mechanized tractor, and maybe in the future, an AI-controlled autonomous tractor. So how do we compare these units of capital? They're clearly not comparable. Again, using prices is fraught with difficulty, but maybe the only way. So we have to worry about distortions in prices due to market power buyers and sellers, and then changes in quality that are not reflected in prices. A good example is computers. Computers today are much cheaper than they were 10 years ago, and even cheaper than 30 years ago. But I think no one would disagree that the quality of computers is much higher today than it was 10 years ago, even more so than 30 years ago. But the same problem arises in labor. We might say university graduates is a kind of labor, but does that mean an NTU graduate is worth the same as an NUS graduate? Don't know. In the Journal of Economic Literature survey 2011 by Chad Syverson, he mentions two more specific issues related to estimation, which are more subtle. One is that more productive organizations will grow faster, they will buy more inputs. So their growth of inputs will be correlated with estimation error, and the coefficients will be biased. Another very subtle issue is selective attrition. The less productive organizations will drop out, so the estimated coefficients represent the productivity of survivors, not the average. So this would be a case where the coefficients will be biased up. But overall, Syverson, who's an expert in productivity measurement, feels that if we are mainly concerned about comparing productivity across organizations, he feels that the inherent variation between establishments, between firms, is so much larger than these possible measurement errors that we don't have to worry about these measurement errors if our main concern is to identify the leaders and distinguish them from the laggards. In the last two slides, let me share with you some estimates of TFP. The first table was produced by Singapore government economists, showing you estimates of TFP by the primal method, labor productivity by the primal method, government estimates of TFP by the primal and the dual method, and government estimates of linear labor productivity growth. You can see that over the years, the Singapore economy has experienced considerable fluctuation in productivity growth, whether you measure as TFP by the Primal method or labor productivity. And this is because productivity changes tend to be pro-cyclical. So when the economy goes up, output goes up faster than inputs, so productivity goes up. But when the economy is in recession, output falls faster than inputs, so productivity goes down. And so you see a cycle in the TFP that is very much coincident with overall economic growth. This is the Asian economic recession. This is another recession. This is the dot-com crash. Interestingly, you see that Singapore's economic performance using the dual method is much higher, much better looking than using the primal method. And this is, according to Chiang Tai-hsieh, who studied this very deeply, a major reason for this difference is distortions in the rental rate of capital, causing distortions in the measurement of capital. And a particular distortion in Singapore is the housing stock. As you know, housing is a very big fixed asset, and it's highly subsidized to the 80% of the population who live in HDB housing. To close, let me share with you 3 pieces of research which were very well known for results on total factor productivity growth. The first is a paper by Chad Syverson published in 2004. He analyzed US manufacturing industries, and his most famous conclusion within US industries was that within an industry, the log of the TFP at the 90th percentile, this is the 90th best performer within the industry, minus the log of the TFP at the 10th percentile, this is the 10th best, the 10% best performer, that's 10 from the bottom in rank, that difference is 0.651. If we exponentiate and rearrange, we have the TFP at the 90th percentile is the exponential of 0.651 times the TFP at the 10th percentile. And the exponential of 0.651 is approximately 1.9. This is just a staggering result. It says that the 90th best performer has a TFP that's almost double the 10th from the bottom. The policy implication is awesome. That is, if we can get all these laggard performers to catch up to the 90th percentile performers, we can double their productivity. The second piece of research also focuses on manufacturing. It's done by Chiang Tai-hsieh and Peter Klenow and published in 2009. They studied manufacturers in China and India compared to the US. The broad conclusion is that manufacturers in China were 25 to 33% lower in TFP than those in the US, while manufacturers in India were 31 to 38% less productive than those in the US. So this shows that from the Syverson study, we know that there's enormous variation in productivity within industry, within the US. Here we find that there's also substantial variation within industry, across countries. The first 2 studies I reported were for manufacturing. For services, Faccio and others published a paper in 2010 of service industries in the UK, and they found that the dispersion of productivity in services was higher than in manufacturing. So to the extent that this generalizes to other countries, it says that the scope for improving productivity in services is even larger than the scope in manufacturing. I should add a proviso that all of these studies use the same production function across the countries and across businesses. This rounds up our brief introduction and review of estimation of total factor productivity. We covered the primal approach, briefly the dual approach, and then touched on some of the more subtle issues in the estimation of productivity. Thank you.